All right, so we're back at it, back at the back side of our notes here. Okay, so we're going to have a little bit of review of what we did on the front side. So this is a good problem to start our notes with because you've had a little bit of time hopefully to digest, at least that couple seconds it takes to click between two links. Okay, so we want to find an angle between 0 and 360 degrees that's coterminal to negative 1,345. So I want to get to be between 0 and 360. So let's think about it. What kind of numbers are between 0 and 360? Well, okay, we have a negative angle up here, but we want to get between 0 and 360. So we want to turn a negative into a positive. Okay, so remember our rule for finding coterminals is I either add or subtract rotations. I either add or subtract 360. Well, if I have a negative, think about it. When I want to start subtracting rotations, if I take a negative and I subtract from it, it's just going to keep getting negative and negative and negative. So what I want to do is I want to add rotations to it, okay? So I take negative 1345 and I add 360 degrees, okay? Don't be afraid to use a calculator for this. If you get stuck, I don't expect this kind of mental math. So now I'm negative 985. Okay, so we're getting closer there, but we're still a negative rotation. We want to get it between 0 and 360. So let's see what happens when I add another rotation. Okay, so negative plus another rotation of 360 degrees gets me to negative 625. We're getting closer. Okay, add a rotation gets me to negative 265. And I can tell by just looking at it that I just need one more rotation. So I add 360 again. Okay, and I end up with 95 degrees. Okay, so 95 degrees is my coterminal angle between 0 and 360. That's the same as negative 1,345. So just to review, drawing angles. Okay, I have my initial side right here. Okay, we call that the initial side. And I rotate to 95. So if it's positive, that means I'm rotating which way, up or down? Positive is always up. So I rotate to 90 and then it's just gonna be just a sliver past 90. So I'm like chilling right here and I rotated this way. So there's my 95 degree angle. It's the coterminal between those. Okay, so now what we're gonna do is we're gonna take these diagrams and we're gonna study triangles within them. Okay, let's see if I can get my camera's not being cooperative right now. There we go. It's just like we're in class again, right? I'm having problems with the doc cam focusing. All right, so here we go. We're going to study triangles within these diagrams, okay? So let's say I rotated from this initial side, okay, to this terminal side, okay? So my terminal side, this is approximately 135 degree angle. Okay, it's not important to our diagram, but what we're going to do is we're going to draw a right triangle to study this angle even further. Okay, so when we draw right triangles, okay, we always want to connect the right angle. And this is a big mistake that students always make, and I don't know why it happens. It's probably because I don't teach it well enough, but we always want to connect the right angle to the x-axis, okay? Because there's two ways I can draw a triangle from this. I can take this point right here, and I can draw a line to the y-axis, or I can take this point right here and I can draw a line to the x-axis, okay? I don't know why, but every year I have students that are taking this and drawing it to the y-axis. We always draw it to the x-axis. So I'm going to drop a line straight down perpendicular like this. So there's my right angle on the x-axis. My right angle should always be on the x-axis. You'll hear me say that over and over and over again, okay? And what we're going to do is we're going to study this little angle in here. And we use a little symbol for this. Okay, it's a Greek symbol. Okay, it's right here. Okay, there's the symbol right there, a little bit bigger so you can see it. And that's the Greek symbol theta. And theta is just a symbol we use to describe angles. So anytime you see theta, it's a variable used for angles. Okay, all right. So we have a right triangle here. And there's three parts of a right triangle that we study in geometry. Okay, so I'm going to change colors here a little bit. So what we have, okay, is we have three sides. We have a side next to it. Okay, remember we call that adjacent. Okay, adjacent. Adjacent means next to. Okay, If we jump across it, okay, we reach what's called the opposite side of the triangle. Okay, and then the side right here that's across from the right angle, that's the longest side of the angle. Okay, think if anyone remembers what that's called. Okay, it's called the hypotenuse. I'll spell that out. I'll spell it right though. Okay, so we have our opposite side from theta, we have our adjacent side, and we have our hypotenuse with theta. Okay, so what we're going to do is we're going to take those side lengths and we're going to study what's called a trig function. Sometimes it's referred to a trig ratio as well. And a lot of people get confused about this. This is your SOHCAHTOA, your sine, your cosine, TOA. Your sine, your cosine, your tangent. A lot of people are like, what are we doing when we're studying sine, cosine, tangent? Because it really doesn't make sense. And I feel like people don't explain what sine, cosine, and tangent are. Well, all triangles kind of interact in the same way. If you have a triangle that has a certain length, it's going to create a certain angle. So there is proportionality in triangles. So what sine, cosine, and tangent helps us to do is it's just a way of describing how the different sides of a triangle, okay, interact with each other, or how they affect each other to create certain angles. Or if we're given an angle, how does the angle affect how long the sides are? It's just a ratio of describing how triangles' side lengths interact with each other. Okay, the first one we usually study is called the sine. So if we're taking sine of theta, not sin of theta, sine of theta, okay, we learn in geometry that sine, SOHCAHTOA, is opposite over the hypotenuse. Okay, hypotenuse. Let's be a good speller here, Riley. All right, so there's our sine ratio. So sine is always comparing the ratio or the relationship between the opposite side and the hypotenuse. Okay, if we look at cosine of theta, okay, cosine, this is, Riley, way to go. This is my adjacent side of my hypotenuse. So it's going to be the relationship between the adjacent divided by the hypotenuse. Hypotenuse. Okay, and the last one is tangent of theta, and this is TOA. This is the relationship between the opposite side and the adjacent side. Okay, so there's our three trig ratios, our three trig functions. Now, here's the thing. When you studied in geometry, you studied triangles kind of just out in space. You just looked at triangles independent of where they were located. Well, when we study triangles in Algebra 2, we study them on a coordinate plane. This is on an XY plane. Okay, so we try to think about it more specifically because you can have a certain triangle, but then how do you draw it if it's located somewhere different? Because you can have the same triangle, you can have 4 different triangles that are located in 4 different locations, and how do we refer to them as being different triangles? Okay, and we do so using the coordinates. Okay, so if we look at the adjacent side of this triangle, okay, let's say we go from right here, because that's our terminal side, that's our initial side where we start, and then we rotate around that. Okay, my adjacent side, where do you notice that's located? Well, it's located on the x-axis, and what your adjacent side really is, this is a distance you've traveled in the x direction. Okay, so my adjacent side is the x direction. Well, if we use that logic, which direction is the opposite side traveling? Okay, well, it's traveling up and down, and which one of my coordinates travels up and down? Well, my y-coordinate. So really what we end up here is we end up with this point right here. And it's actually a location on the plane. We are rotating a certain amount to create this triangle, but we're also locating our triangle by this point. And so this is our XY coordinate point right here. So we can actually draw a triangle using a coordinate point and not just a rotation. Okay. For the hypotenuse, we use the variable r for hypotenuse. So anytime you see the variable r, that's my hypotenuse value. Okay, so let's break this down into different terms. Let's break this down from geometry class to algebra 2 class. So in this case, our sine, which is opposite over hypotenuse, okay, now using our variables, opposite is what variable? Well, that's our y variable, so it's y divided by my hypotenuse, which is r. Okay, cosine is my adjacent and my hypotenuse, so that would be adjacent is what variable? What's my x coordinate divided by my r. Okay, and last one, okay, we have our opposite, okay, and our adjacent. So it's opposite over adjacent, that's y over x. So this would be y over x. So there's my sine, my cosine, and my tangent in terms of x, y, and r, okay? So here we go. Moving on, we're gonna start using this now. You guys got this, I believe in y'all. Okay, just remember at any point, okay, if you get overwhelmed or stressed, just take a deep breath. We're all working through this the best we can. Okay, feel free to send me an email or invite me to a Zoom meeting and we can talk through this more too. But I believe in y'all. If you put your effort in and you try your best, it's gonna be okay. All right, so given that the point -4, 5 is on the terminal side of an angle, find the exact value of the following, okay? So remember, this is an XY coordinate pair. Okay, so what we can do is we can draw that point in space. Okay, so I'm gonna draw a diagram here. Okay, this is gonna be beautiful. You guys are all gonna be super impressed by this. So here's my x-axis, here's my y-axis, okay? Here's my initial side, so this is where we always start our rotation, okay? So what we're gonna do is we're gonna figure out, okay, where in space am I located? Well, my x value is -4. Well, if I go -4 in the x direction, -1, -2, -3, -4, it doesn't need to be perfect. Okay, and I go 5 in the y direction, 2, 3, 4, 5. That means my rotational point on the terminal side is right there. So this tells me, I'll draw this in my beautiful pink pen here. This tells me that this is my terminal side right here. Okay, that's my hypotenuse. That's my R value. Okay, and then I can draw my diagram. Okay, now where do we always connect our triangle? Do we connect it to the y-axis or do we connect it to the x-axis? Because there's two triangles we can draw here. One of them's the correct method, one of them's incorrect, and this is where we make mistakes. Okay, we always connect to the x-axis. So I'm going to draw my right angle right there. That right angle is on the x-axis. So here's my x coordinate, here's my y coordinate, and here's my r coordinate. Okay, some of this information is given to us. Do we know what our x coordinate is? It was given to us to start the problem. What's our x coordinate? Well, we know this is -4. What's our y coordinate? Well, it was given to us to start the problem. It was 5. Now, here's where we reach a little bit of a problem. Do we know our r value? Do we know that hypotenuse length? Unfortunately, we do not. Okay, so we have to rely on some more geometry terms here. Something else you learn in geometry. Okay, and some of you might be popping your head right now. You might be yelling at the computer or your cell phone. Okay, but we have to use what's called the Pythagorean Theorem. Okay, so remember the Pythagorean Theorem states that the two legs of a triangle squared, so a squared plus b squared, when you add those together, they will always equal the hypotenuse squared. Remember, this value always is the hypotenuse. It's not as important which one you label A and B, okay, but we know that c squared needs to always be the hypotenuse. So in our case, if we translate this to our algebra 2 terms, we know that x squared plus y squared has to always be r squared. So what we can do now is we can solve for that hypotenuse length. Well, what's our x coordinate? It's -4. So -4 squared plus, what's my y coordinate? 5 plus 5 squared equals r squared. Okay, so -4 squared is 16 because a negative times a negative is a positive. If I see any of you on your homework write that that's -16, after all the talks we've had in class, Mr. Riley is going to start pulling some hair out. And you know how much I love my man, but I don't want to do that. 5 squared is 5 times 5, which is 25. So we get 41 equals r squared. Okay, well, we want r, not r squared. Well, what's the opposite of squaring something? We square root both sides. So square root of 41 equals r. Now, I know we have this talk a lot in class. Okay, anytime you square root something when you're solving, how many solutions do you have? You have 2, right? You have a positive and a negative, plus or minus. Well, in this case, we're talking about the length of a triangle, okay, the length of a hypotenuse, okay, and we're not going to have a negative terminal side length, okay, so we always want that positive hypotenuse. Okay, we can have a negative x length because this is telling me to travel in the x direction, a certain direction, but we can't ever have a negative hypotenuse. Okay, so now we have our r value. We can throw that in here. We know r is root 41. And when you go to do your homework, okay, you can use when you go to type an answer, there's a little yellow arrow off to the side of your answer box that you can click on that allows you to do square roots in your answers. And you can actually leave these all as fractions as well in your answers, okay? So sine, okay, well that's y over x. Well, what's my y coordinate? It's 5 over y over r. My r value is root 41. And that'd be your answer for sine. Okay, cosine is x over r. So my x is -4 over root 41. And that'd be your answer for cosine. Tangent is y over x. So it's going to be 5 over -4. And those are your 3 values there. Okay. So when you go to type this in the computer, make sure you click on that yellow arrow in your answer box, which allows you to type it. It allows you to push a button to get a fraction. Okay, the button actually looks very similar to what your button looks on our yellow calculators that we used to use. Okay, it'll pop up like that. There's also a square root button. If you need that, you can put that as square root of something. Okay. All right, so that's one set of problems you'll have on your homework. We have one last set to do, and we're going to call it a day. I appreciate all you sticking with me for this long. Okay. All right, let's see if we can get this zoomed in. I swear it's just like we're in class. All right, so this one's only asking us to find sine and cosine, and it gives us the tangent value. Okay, it gives us the tangent is 7/4. Okay, 7 over 4. So if we look back up here, okay, tangent is y over x. Y over x. So this tells us our y value is 7 and our x value is 4. Sweet. Now I can draw a diagram. Here we go. X is 4, 2, 3, 4, sure. Y is 7, 1, 2, 3, 4, 5, 6, 7. Doesn't need to be perfect, so we're right about here. And I draw my angle. Okay. Now, this is an important lesson in reading a problem completely. Because if I read this problem completely, we got the tangent, which gave us the y and the x. We know we have to find sine and cosine. So the one piece of information that I didn't read, okay, and the reason that I made this mistake is to show you that it needs to be in quadrant 3. And we talked about this at the beginning of our notes, okay? But when we draw diagrams, there's 4 different locations or 4 different quadrants we can be. Quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Okay? This tells us our diagram needs to be down there in quadrant 3. Based on this that I drew, I'm in quadrant 1. So I have not drawn the correct diagram, which means my sine and cosines are not going to be correct. Okay? So let's fix this. Okay, well, how did I end up with a positive ratio if, okay, if I have a positive x and a positive y? Well, if you divide a positive by a positive, it'll keep your ratio positive. Well, how else can I end up with a positive ratio? Well, it would happen as if it was a negative divided by a negative. Okay, so we got to take into account where we are in our quadrant. Okay, so if I draw it in quadrant 3, my x and y are going to have the same value, just in a different direction. Okay, so my x value is still 4. It's just 4 in the negative direction. My y value is 7 in the negative direction. 1, 2, 3, 4, 5, 6, 7. So we end up down here. Okay, so this is my terminal side right here. That's my terminal side. Okay, here's my initial side. Okay. All right, so now when we go to draw our triangle, we're in quadrant 3 now. There's 2 ways to draw your triangle. You can draw it to the y-axis or the x-axis. We always put our right angle on that x-axis. So there's our right angle. We have our x side length, we know is -4. We have our y side length, which we know is -7. How do we find the r value? Good old friend Pythagorean Theorem. Okay, so x squared, it's pink pen, plus y squared equals r squared. So 16 plus 49 equals r squared. Okay, 16 plus 49 is 65. And then we square root both sides to get root 65 equals r squared, or r. Okay, so we have root 65. So now I can finish the problem. I can find sine and cosine now. So sine, here's our theta right here. Sine of theta is y over r. And cosine of theta is x over r. Okay, and that'd be your final answers. Okay. All right, so that's all I got for you today. I know it was a lot to take in, but you have a week to kind of digest it. What I need you to do now is use these notes as guidance. Okay, have them out next to you. Okay, I'll post a paper copy of my notes. You have the video that you kind of walk through with, hopefully, either in a notebook or on the printed paper. Okay, use these to help you. Okay, so work on your practice problems. Okay, once you complete your practice problems, I want you to hopefully have them done by Wednesday-ish, because on Wednesday I'm going to post a short little quiz for you to work on. Okay, I look forward to seeing you guys on Tuesday for 4th period and Wednesday for 6th period. I'll go over how to access all this different information, but please try your best to access this video, work on your WAMAP problems, and then send me an email or set up an office hour visit on Zoom to go over these problems. Try your best. Know that I'm here to support you. Okay, look forward to seeing you guys. Bye.